So the experience of and the background of our next speaker is amazing. He has insights, as you know, both in large corporations in Silicon Valley as well as startups. His work at O'Reilly is very interesting from a perspective of a conference organizer. Paco Nathan's talks are always very inspiring. This is the nth time he accepts to come to Madrid to speak to us. And his insights today about machine learning, how organizations and teams can exploit the new technologies is something that I think is very strategic, high level, but I am sure that you will find sources of inspiration in everything he's saying. So I would like you to please welcome Paco Nathan. Thank you.
Buenos días y muchas gracias. Thank you very much, Ruben. I appreciate it. I'm grateful to be in Madrid and at Big Data Spain. I'm very excited about the presentations here. My talk is titled about human in the loop. And as Ruben mentioned, this is about a design pattern for how to manage teams in the context of AI, teams that are using machine learning at scale. So in my work, over the past year, I've been leading internal development of AI in media, a lot of applications of machine learning. We front for more than 200 publishers, and we're applying these techniques to a lot of learning content, books, videos, etc. Also, I've been hosting the executive briefings at Strata Conference, and I hope to weave in some of the insights that we see emerging in enterprise, in industry, across a number of verticals with respect to artificial intelligence. Okay, so just to frame this, I would put out a what if. Imagine if you could have a mostly automated system where people and machines collaborate together. And though it may sound a bit science fiction, really a lot of this happens every day. So the idea is if you have an e-commerce system, it's online, there's transactions, but there's also customer support, and there's product management, and there's all the engineering that's going on, all the operations. You have machines and people working together. But what I'm curious about is to take this steps further. As Oscar was mentioning much earlier today, the notion is, can we move beyond tasks into more complex kinds of decisions being shared by people and machines? Can we have people training machine learning through examples? Not just writing code, but actually real human kinds of discussion about examples of what to do. So I'll throw that out as a kind of frame for where we're going. Okay, this is a little bit earlier version of my slides, but no problem. We'll work with this. So really, the emphasis here is about personalized learning, at least for our company. We front for a number of publishers. We have thousands of enterprise organizations, more than 4,000 that subscribe. And we have to work with a lot of new content coming in every day. But what we're looking for at the end of the day is to provide some more forms of personalized learning for the customers. So, what I want to show here, this is a prototype UX for a new search page. And again, this is for hundreds of publishers. The notion being, though, that the search query mechanisms, the interaction on the user interface, and the results that are being shown, part of that is created by people, and part of it is created by AI. So when we look at, for instance, the query expansions, that's being done through deep learning. When we look at the summarizations per chapter that show up in the search results, that's being done by deep learning. When we look at how the videos are being indexed, we use AI services from Google to be able to get transcripts, and then we run NLP across it. So it is a kind of blending of both machines and people for the kind of output that we need. And in terms of AI in media, you know, if you have content which is text, then you can move forward, use NLP, And once you've done some parsing and other processing, you can move into a variety of different applications, deep learning, et cetera. If you have data which is labeled, data which is images or video that has labels on it, it gets very interesting. But one of the things that we have to work with is we assume that this data has structure inside of it. We assume that when people are writing tutorials, there's a purpose, there is a narrative, there is an intent. So we have to find that. One of the problems, though, is that representation for that kind of structure in learning materials, in media, it's still needing to catch up. It's nowhere near like what we'd see with, say, self-driving cars. So that's what we're working on. There. So as an example, here's a video. It's very popular. It's an introduction to Docker. This is by Andrew Baker. And up in the top left corner, what we did was took an MPEG out of the video and ran it through Google's asynchronous transcription service. Again, AI services in the cloud. We get back a transcription. We run some deep learning to post-process. And then we run it through NLP. We get a parse. We run it through some graph algorithms. And we start to pull out annotations. What was this person saying? And so directly from the audio of this talk in this video, we're able to get some annotations down here. Those feed back into knowledge graph, an ontology, which is shown over here on the left. Part of that ontology is made by people. Part of it is actually generated using deep learning. So we're experimenting with ways of also augmenting and generating ontology. So that's an example of actually 3 or 4 different AI applications in media. Now, I would say that AI is real, but why? And so really I'm borrowing here from, I believe it was Andrew Ng that came up with this, but there are 3 components. So we'll say that 3 things happen to make AI real now. One of them is big data, and so this happened following the successes of e-commerce, really coming out of the late 90s. Then there was big compute, which is to say cloud. And that really caught traction 2003, 4, 5, 6, because of lightweight virtualization. A lot of work that was going on with hypervisor, and then subsequently what was going on with hardware virtualization, and then of course leading into Amazon AWS, et cetera. And thirdly, the thing we needed were big models. And so there have been neural networks, a lot of research in machine learning for artificial neural networks ever since the mid-1940s. But I worked on some of this. I did about 7 years of R&D in neural networks back in the 80s and 90s. We did not have the hardware at the time to really make a lot of effort. But what changed is that with the advent of big data and big compute, now we could start to get big models. And so around 2009, when NVIDIA started using GPUs for training much, much more substantive structures, deep structures in neural networks, there was an inflection point. And that's also a time when the NIPS workshops really took off. So we can see that these 3 factors then came together and they created an environment where we could have AI be real and start to go into consumer products. But I believe that there are other components coming in as well, so I want to make the case for that. All right, and so this is really where, when I'm talking about AI, what I try to go back to as a touchstone is whenever we can reach some kind of human parity. So for instance, I'm working a lot with video and transcription. We pay for services in transcription. Microsoft in 2016 was able to beat the benchmark for having machines produce transcriptions with less errors than what humans would be doing. So I think that that's a good kind of definition to work with for AI. Okay, so when we talk about machine learning, just as some background, typically people are talking about supervised machine learning. And that is to say that you've got a data set, and every row in the data set has a label, and you can train a model on part of the data, test it on the rest of the data, and the idea is you're trying to predict the labels as new data comes in. If you have large data sets and lots of labels, then you can get into doing deep learning as a very popular example of this. There's also the unsupervised machine learning, which is to say that regardless of the labels, we can put the data into algorithms like k-means. Clustering is one that's very well known. And these kinds of algorithms will work with the data to be able to show where the structure is, assuming that there's some kind of structure, some context, something embedded inside the data. We'll try to find that. And so there are a number of variations on this. But again, unsupervised learning is very interesting. It's still not clear. There are research efforts toward using this for AI, but that's still very much an open question. One area, though, that hasn't received as much attention, but is beginning to really emerge, and what we'll focus on here, is active learning. It's a special case of semi-supervised, and the idea is you can train machine learning models. Maybe you have an ensemble of machine learning models. You train them, and they will go and try to make predictions based on the data. If they have confidence and they can vote together to produce a prediction, great. That's automated, use it. But if they do not agree, if they do not have confidence in how they're voting, then kick it back to a human expert. And the judgments made by that person feed back in to train the models further. So this is called active learning. It's also referred to as an instance of human in the loop. And it's what I want to focus on because I think it's a very good rubric, if you will, for blending people and machines together. Okay, let me see. Hello? Can you advance to the next slide, please? Nope. Test, test. There we go. Oh, I went a little too far. There we go. Thank you very much. Now, I want to talk a little bit about data rates because I think it's very important when you consider machine learning applications. This is a great quote from Jeff Dean very recently. He was talking about the context of deep learning. And what he's saying is that if you have a data set with hundreds of thousands of things and they're carefully labeled, then you can get into doing deep learning. If you have only 10 examples, no. Now, there are some caveats here. You could be using transfer learning, where you train up a structure, a model, on a very large data set, but then just reuse most of it, all but the top few layers, reuse that for a different application, maybe where you don't have as much data. But still, overall, it's a good caveat that you do need a lot of labeled data to be able to get into the game with deep learning. Hello? Could we advance to the next one, please? There we go. Perfect. So I wanted to show here a log scale of data rates. The idea is that deep learning is over here. If you have hundreds of thousands of elements, if you just want to be doing supervised machine learning, it's orders of magnitude less as far as the requirement. Active learning, though, really just even a few data points. You can start getting this kind of human in the loop going with active learning. So it's what you should be looking at, I believe, if you have much less labeled data, if you want to bootstrap into that situation. If you do have a lot of data to use, deep learning is great. Reinforcement learning is going to take orders of magnitude even more. Much higher data rates are really required, although I think that reinforcement learning is extremely interesting in a lot of industrial applications. Okay, next slide, please. Great. So here's it's just a sample, but I wanted to point out, and I have the slides online already. We'll be posting them on Twitter, and there are links to all these companies here. But these are companies that are working with active learning, some very, very interesting use cases. We tried to put together case studies. There we go. So there's a free book here, a free download, a mini book about active learning that looks into some of the practice. Really, it's a case study about a company called Crowdflower. And Luc Biawald started this. I got to work with him really about 8 years ago when he was first getting started. And it's really fascinating, but it's taken a decade for the industry to understand what kind of service they were providing. And now they're finding out. Another one that's using active learning is Stitch Fix, a startup in San Francisco where they send you fashion. They pick out clothes for you to wear, and they send you ensembles. And if you don't like it, it goes back free. So they use machine learning to be able to pick out for individuals and personalize what they think they would want to wear, but they also have this human in the loop aspect to improve the quality. And I think it's just brilliant. Another one is Clara Labs. And what they have is a kind of bid-ask system where you can think of basically a continuum. If there are tasks that are simple enough that can be automated fully, great, machines can do that. The price on them drops down to a lower rate, whereas if there are tasks that can't be performed by automation, it slides the other side, and the rate goes up. and people bid on those tasks. So this is a two-sided market where both machines and automation are participating and bidding on different types of tasks, and it's a way of basically filtering out where's the dividing line between what people do best and what machines do best. It's a great case study about it. There's others related. Another one like it is B12, and with Adam Marcus, really interesting. They're automating business website design. So as a business customer, you come in and describe what kind of business website you need. And really, it's only the last mile where the people get involved. One of the things that Adam talks about that they're involved with is the notion of flash teams. I believe that Accenture sponsored this research at Stanford, but it's a little bit beyond crowdsourcing, a little bit higher abstraction layer, if you will, of getting teams involved in kind of active learning situations. And definitely weak supervision, while it's not active learning, this is a research project called Snorkel out of Stanford. It's a follow-up to something called Deep Dive. They are definitely working with a human-in-the-loop kind of pattern. It's not active learning per se, but it's another way of blending the results of what you see out of different human experts along with what you're seeing from automated machine learning decisions. Okay, so for our work, we worry about disambiguation, and that's where we're applying active learning. And I threw a slide up here of just some screenshots, or sorry, some stills out of Firefly and The Expanse, two very different kinds of science fiction TV shows. But arguably, if you're looking at big data and you're just trying to draw correlations, one of the problems is it's really hard to disambiguate if things overlap too much. And that's what we're working on. It's something that NLP libraries so far don't really have a lot of support for, but it's a great application for human-in-the-loop. So here, say somebody is looking for the term iOS in a search engine. They want to learn about iOS, and they revise it further, and they say they want to know about iOS as an operating system. Okay, that's great. It's still ambiguous because are they talking about Apple smartphone operating systems? Are they talking about Cisco Switch operating systems? And there's a lot of instances of this, where the same keywords, same phrases end up having ambiguous overlap in context. So what we've done is to build machine learning pipelines that use Jupyter for disambiguation with active learning. And some of this is open source. We've got it up on GitHub, but it's definitely making use of NB format and pandas and scikit-learn. The idea is that the notebooks are serving as one part configuration file, one part data sample driving the active learning. They're also kind of a structured log of what's happening in the pipeline, and it's a way for people to jump in and inspect what's going on in the pipeline as a data visualization tool. So it's interesting here because the way that we train these pipelines, the people are not doing modeling or feature engineering or any of that. That's all automated. People just show examples of different contexts, and they try to split, again, is it iOS Apple or iOS Cisco? I'm not going to go into too much detail. If you want to look, though, these are the steps that we go through in this pipeline and where it is. But again, the basic idea is that machine learning can do most of the work. But when we hit an edge case that machine learning can't agree on, then experts are basically notified to come in and make a judgment, and that feeds back in. It gives us a loop. So just to show this a little bit here, as an example of something where we're using React. And the word React, of course, to a lot of people, if you're working in front end, that means it's a JavaScript library. If you're talking about managerial soft skills, you're probably talking about how people react during an interview. If you're talking about reactive programming, this is something else in terms of Akka and others in Scala. So just even a simple word like React could mean vastly different things. But we have pipelines that are built up, and the Jupyter notebooks are used in a way that you can think of them as shared documents, where the collaborators on the documents, some of the collaborators are machines, and the other collaborators are humans. And this is anticipating new features coming out in Jupyter based off of Google G Drive, where you have shared documents like that. There. Okay, now, In terms of active learning, if you look at the literature, there are different types of policies, and this is definitely using a bias toward exemplars policy. The notion there is we have so much content, we really want to recommend the best for anybody in a particular context, again, to give them personalized learning experiences. So what we want to avoid is giving bad recommendations. There's far too many recommendations we could make. We want to bias toward the better ones. But an interesting thing that comes out of our policy and our implementation is what we found is that the people feeding in expertise into AI, in this sense, are not necessarily your technology team. It's very likely that the people who really know what the customers need are closer to the customer service organization or the sales organization, maybe marketing, and non-traditionally not the technology people are the ones who end up then training AI. I think that will be a fundamental shift. So, sorry, quick. One more slide. There we go. So I want to talk about management strategy. In terms of big data, we usually talk about workflows, and we have a notion of something called a DAG, a directed acyclic graph. We see this in Hadoop and in Spark. We see this in Beam and many other projects where there's this DAG at the center of it. And it's really part and parcel of how people manage data-driven organizations. But essentially, it's a very linear kind of approach. This has worked out very well for big data. One of the problems is, though, you really want to avoid, of course, garbage in, garbage out, so you spend a lot of time on data cleanup. But again, it's kind of a linear process that it's led toward. And instead, what we're seeing after we introduced active learning, human in the loop, we see more circularities becoming introduced. And so the idea there, if you look in literature about design and some of the issues of design thinking around cybernetics, you'll hear about second-order cybernetics. It means that there are loops, that there are circularities. So there are feedback loops. So essentially, we're creating situations of having dialogue with the machines that are doing a lot of the automation. As I mentioned, using shared documents, using pipelines that people can jump into. And I think that this is a really good model for people and machines working together. You want to prioritize your people's time, your expertise being spent on really the edge cases, the hard problems, and injecting that into the whole system to give it more and more intelligence. Although I do think it stresses some of the current process, because before we've had big data as kind of a linear flow, and now we're introducing circularities. And I think that there are going to be problems. We're already seeing this. I think product management in particular is somewhat put on notice. So an essential takeaway here, though, is that depending on the organization, some of the key ingredients to make AI work right now, I think, come from non-traditional sources. They will be coming, again, like I say, from your customer support and from your sales organizations, maybe marketing and others. So I wanted to go from there and talk a little bit, just wrapping up, about trends. What we're seeing from O'Reilly perspective, we work with these conferences, and we work with a lot of innovators in industry. And just to summarize, there are three areas. One is about hardware, and so there's a very long-term narrative about putting successfully more and more advanced mathematics into the hardware layer. And we've seen this. This is definitely part of what's driven GPUs. Now it's going even further into other rapidly evolving hardware, TPUs, IPUs, et cetera. I never thought that I'd see FPGAs coming back, but hardware is advancing very rapidly. And contraindications on this, programming languages that have been popular, that abstract away the hardware, are becoming less popular. We see that Python now is much more popular than Java. We see other languages like Go and Rust and Node also really coming up, again, because they allow access to the hardware. And I think that this is a problem with software where, in some ways, the popular software stacks aren't able now to keep up with how rapidly hardware is advancing. That'll be a major shift. Things like Apache Arrow, I think, are addressing this. Another issue is software. I think that we're seeing progressively more and more subsystems being taken over by really cognitive software, right? Pattern recognition, planning, scheduling, these different types of areas where AI is moving into. Now, A contraindication on this, though, is that there's really, some people expect that there's only incremental change for software engineering practices. And I think that's wrong. I think software engineering practice is in for some very radical changes. And again, product management is probably an area that really needs some revamp. To support that, here, come on. One more slide, please. There we go. Yeah, so to support that, I have some links here. Like I say, I host the exec briefings, and we've had McKinsey, Deloitte, Accenture, Telefonica, Cloudera, across the board, all these large consultants come in and basically say much the same thing. There is so much upside to be gained across many different verticals because of AI, and it's very real, and McKinsey in particular has done projections which are outstanding. I definitely point you toward them. However, what they're saying across the board is, unless you have your company set up for cloud and for site reliability engineering and for breaking down data silos and for having data infrastructure and having good data science practices, unless you get those things in order first, you're not going to be in the game for working with AI. And it's very crucial because there are not many enterprise organizations that are really set up for this yet, and we're going to see abrupt changes. So again, software process, I think, is up for some very, very distinct changes, nonlinear changes. One more slide, please. Hello. Sorry. Can we advance to the next one, please? There we go, great. Okay, and people, again, I mentioned that there are circularities. And so one of the things I really like, there's a great talk that's linked in here from Russell Stanley, who's at Uber AI. And he's done work on neuroevolution. And I think it was one of the best talks that we had at the AI conference in San Francisco a couple months ago. But the notion there is that we're seeing a shift away from real linear kinds of objective functions into having fitness functions. And this applies to how the people work with the software. I wrote an article, there's a link to it, about some of the changes we see in software. And in particular, I had picked out a couple of talks from Peter Norvig, who's head of research at Google. And he's done talks at some of our conferences recently about how different software engineering is when you introduce machine learning at scale. That software engineering with AI is just not what you expect. The processes, again, are becoming much more circular. So I'm almost out of time. I'm going to just have this one thing here that we said big data, big compute, and big models. I'll add big team. The idea that, again, integrating human in the loop, integrating non-technical parts of your organization, their expertise, is essential for making AI happen. And I don't think it's about replacing people. I think it's about augmenting people. We definitely see this. And while that's my opinion, the opinion of my employer is very much the same. And I'll definitely recommend, Tim has a book out now called What's the Future from Tim O'Reilly. It's just come out, and it addresses a lot of these issues. So if you want to get a hold of me, I've left some contact info here. Thank you very much.